Hey guys, we're going to look at some more simplifying of radicals. So let's start off by looking at these two radicals. We're going to try to add them together. So the way they look right now, we cannot add them together because the radicals are different. So what we can do is we can try to simplify each one first. So the square root of 40, remember we want to see if it has any perfect square factors. So let's look at our perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. So do any of these factors belong to 40? Well, 4 does. 4 is a perfect square factor. So that's going to give us the square root of 4 times the square root of 10. And we know that the square root of 4 is 2. So we have 2 square root of 10 plus the square root of 10. Hey, look, the radicals are the same. So guess what we can do? We can add them together. Not the radicals, but we're going to add the leading coefficients. So it's going to be 2 plus 1, and that's going to give us 3 square roots of 10. We never add these numbers together. We never add these numbers together, never. Okay? So let's look at another example. This time we'll go ahead and do a subtraction problem. Okay, so notice when adding and subtracting, you have the two numbers have to be like terms, and since the radicals are different, we cannot subtract them. So again, we're going to try to simplify the radical. So looking for a perfect square factor, 25. And I always like to put that one first. 25 times 2 is 50. So we end up with the square root of 25, which is 5, radical 2, minus 3, radical 2. And remember, when adding and subtracting, the radicals don't change. It's the leading coefficients that you add and subtract. So 5 minus 3 is 2, and the radical stays the same. Okay, so let's now take a look at a multiplication problem. Let's just make one up here. We'll do the square root of 18 times 3 square roots of 2. Okay, so we could approach this a couple different ways. We could either start off by multiplying. So when multiplying, you can multiply the radicals together. So if we take that route, okay, we would end up with 3, because this is a 1. 1 times 3 is 3. 18 times 2 is 36. And then we'd have 3 times, and the square root of 36, that's one of our perfect square factors, but the square root of 36 is 6. That gives us 18. The other route we could do here is we could have simplified the square root of 18, which is going to be the square root of 9 times the square root of 2. And then the square root of 9 would be 3 square roots of 2. And we're multiplying that times 3 square roots of 2. Then we would multiply our coefficients, so 3 times 3 is 9. Radical 2 times radical 2 is radical 4. And then the square root of 4 is 2. So we have we have 9 times 2, which gives us 18. So 2 different paths to get the same answer. Okay, so here we have a monomial times a trinomial, 3 terms, 1, 2, 3. And so remember, to simplify this, we could start off by simplifying some of these in here, or we could distribute the square root of 3 onto each one. So I'm going to go ahead and do that, even though it may be simpler to do it a different way. So 2, this is going to be a leading coefficient of 1, so 1 times 2 is 2. Radical 3 times radical 4 is radical 12. And then we have 1 times negative 1. Radical 3 times radical 6 is radical 18. 1 times 5 is 5. And 3 times 9 is 27. Now notice that these radicals were all different, so we couldn't combine any. Same thing here. All the radicals are different, so we can't combine any. So at this point, we would want to simplify these. So looking for a perfect square factor. So I'm going to use 4. And here I'm going to use 9. And here I'm going to use 9 again. Here we get the square root of 4, which is 2. 2 times 2 is 4. So we have 4 radical 3 minus square root of 9 is 3. So we have 3 radical 2. 3 times 5 is 15. So we have 15 radical 3. Okay, now of these 3 terms, can we combine any of them? Yes. See that these 2 radicals are the same? So we can combine those 2 terms together. So remember, when adding and subtracting, we do not add and subtract the radicals. We add and subtract the leading coefficients. So 4 plus 15 is 19. And then the radical stays the same. And then we bring the other one down. And we've gone as far as we can.